All right, so just a quick overview of how to use Microsoft Excel to compute moments of inertia. And this was the example that we did in class. I've just sort of screen capped it here to make it a little easier to reference. What I'm going to do is I'm going to sort of repeat the calculations that we did in class, but I'm going to do them inside Excel. So maybe our answer changes a little bit, but Excel is going to be taking care of a lot of the rounding for us. So the first shape that we used was this rectangle. Maybe what I'll do is I'll use my mouse here to sort of do that because I don't have my pen with me. I'm using my desktop here. So let's go back to this. So what we're doing here is we're splitting this up. So the first shape was the rectangle. So remember it was 10 times 8. And so I'm using the formulas inside Excel. So equals 10 times 8. So that takes care of that. For the triangle, that was shape 2, so that's 8 times 8 divided by 2, b times h over 2. 3 was the whole, so that was pi, so in Excel you do pi times that, or like that, times the radius squared, and so if it's a 3-inch diameter hole, it's 1.5 inch radius. And then I need to put a negative in front of that because it's a hole, so it's negative. And then for the semicircular region, we had pi times a radius of 4. But it's a semicircle, so we have to divide it by 2. So there's the numbers that we got in class. And so here on the bottom, I'm going to put a sum. And then we just do sum equals sum, and then parentheses, C3 to C6. Now, I'm doing this kind of quickly, by the way, so if you need to pause or go back, that's the beauty of YouTube. So let me also do a little bit of formatting. Let's, maybe, I don't know, do that, make that, like that, and then we'll grid this up so it's a little easier to see. Okay, now the y distances, again, we're doing the y from the bottom. So for shape 1, that was 8 halves or 4. For the triangle, it's 8 over 3. For the circle, or the circular hole, it's 5 up from the bottom. And this was 4 up from the bottom. And so now when I do a times y, I do a times y. And then I can Control C and Control V, or in Excel you can take the mouse cursor to that corner, see how it turns into a black plus, and I can drag down and it'll fill in that way. And then since I've already got a sum formula here, I'm just going to copy and paste that because it's a lot easier. So bam. So for the centroid, so what I can do is put the centroid right here, that divided by that, boom, there's your centroid, 3.62 inches, really easy. Okay, for the moments of inertia, what did we have? We had 10 times 8 cubed divided by 12. We had 8 times 8 cubed divided by 36. We had a negative here because this was the whole, and this was 1/4 times pi times r, which in this case was 1.5 to the 4th. And we had the semicircle, which was 1/8 times pi times r to the 4th. Okay, now here's the kicker on Excel. So remember that these d distances are equal to the y minus the centroid. So the way that you set this up in Excel is you say equals y minus the centroid, but what you have to do is you have to lock the centroid cell. So you can hit F4, or you can put $ in front of the D and the 9, so that when you drag this formula down, so for instance, if I, let's say, look at this one, it drags the reference down for the y, but not for the centroid. It keeps that locked. So we lock that in, and then we do I plus A times, and then D squared. And then just copy that down, sum that up, and boom. there is your moment of inertia. So I think when we did that in class, I think we might have gotten 667.6, but that was just rounding and whatnot. But yeah, that's how you do it. Pretty straightforward, pretty simple. Hopefully that helps explain how you can do that in Excel. I have no problem if you use this to supplement your homework assignments, as long as it's all in one file. Makes it easier for us to grade. And with that, that's all I've got in this video.